All right, everyone. Welcome back to another exciting day in, what class is this? IBSL1. I got it. You guys, today we're finally going to be starting the Binomial Theorem. Dun, dun, dun. You guys, this is probably the first topic that you guys have never seen before. So it's a really interesting unit to see, how you guys are learning new topics in this course, because really it's been a lot of review up until now. I want to start by taking this problem, expand x plus y cubed. Remember, that is not x cubed plus y cubed, so this does not equal x cubed plus y cubed. Wish it worked like that, but that's not the world we live in. You guys, x plus y cubed, to cube something, you have to multiply it times itself 3 times. So here I have x plus y times x plus y times x plus y. So to be able to expand this, I first am going to take the back two terms, x plus y and x plus y, and FOIL them, or distribute, or box method, whatever you do. And I'm just going to let this guy in front just hang out. So this guy right here is just going to chill, and then we'll deal with the back two, and then we'll deal with everything. So front one gets to hang. Hope I left myself enough room. X plus y times x plus y. Well, first it would be x squared, and then you would get xy plus xy, so that's plus 2xy, and then this would be y squared. Then you need to take every term in the back half and multiply it by x. So you have to distribute the x to this, to this, to this, and then after you've done all that, also distribute the y to here, here, and here. So if I'm taking 2 terms and multiplying by 3, I should end up with 6 terms total afterwards. So let's see, x times x squared, let's maybe move over here, is going to be, am I going to have enough room? No, let's do it down here. X cubed, and then x times this guy is going to be plus 2x squared y, and then x times y squared is going to be xy squared. So that was me multiplying all the x all the way through. Now I'm going to multiply the y all the way through. When I multiply y with x squared, we get x squared y. I'm going to keep the x's first and the y's second. Then y with 2xy is 2xy squared. And then I have to multiply the y with y squared to get y cubed. Let's count them up. Make sure I got them all. 1, 2, 3, 4, 5, 6. Yep, 2 times 3 should be 6 things. Now, if you guys look at this, there's some like terms in here. So let's see. Anything that ends in an x squared y, here I have an x squared y, and here I have an x squared y. Also, anything that ends in an xy squared is going to be like terms. So here, there's an xy squared, and here there's an xy squared. The x cubed doesn't really have anybody to combine with, and the y cubed is similar, that it doesn't have anybody to combine. So this becomes, let's say, write the original problem, x plus y cubed is going to be x cubed plus 3x squared y, because 2x squared y and 1x squared y gives you 3x squared y. And then it's going to be plus 3x y squared plus y cubed. That's our final answer. So that's x plus y cubed expanded. Now, wasn't that long and tedious and prone to making mistakes? Usually we are. Let's take a look at if you were to expand a lot of different binomials. Oh, binomials, by the way. This is a binomial right here because bi means 2, that there's 2 nomials in there. Nomials are just little algebra chunklets. If you take x plus y and raise it to the 0 power, well, anything to the 0 power is just 1. If you take x plus y and raise it to the 1 power, well, you're just going to get itself, so that's x plus y. If you square x plus y, you could FOIL. We've done a lot of those, and you get x squared plus 2xy plus y squared. If you cube it, we just did that. We got it. It was x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, I could ask you guys to raise something to the 4th power, but it would be annoying because you would have to FOIL 2 terms, then multiply all those terms times x plus y and combine things, and then multiply all those terms times x plus y and combine things. It's not hard, it's just tedious. Trust me that you would get this. X to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Also, trust, fam, that if you raised it to the fifth power and did a ton of algebra, you would get this. X to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus y to the fifth. Now, this is the point where if it was a live class, I would say, hey, do you guys notice any patterns here? And then we would all look at it and somebody go, oh yeah, oh, Susie has her hand up. Yeah, what do you notice? Susie's like, well, I noticed that all the x powers are always descending. Like here in x plus y to the fourth, like it goes x to the fourth, x cubed, x squared. This is x to the 1 power. And then here, you can think of this like x to the 0 power, because x to the 0 is just 1. Nice observation, Susie. Anybody else? Yes, you in the black shirt, Mohammed, what do you see? Well, I noticed that the y powers are kind of like the opposite, that here, like there's no y power, but then this is y to the 1, y squared, y cubed, y to the fourth. So the y powers are ascending and the x powers are descending. So you get this kind of crisscross thing going on, that it's like, you know, your y's gain and the x powers decrease. So it's like, you can see that in the x to the fifth example, that or x plus y to the fifth, that it goes x to the fifth, x to the fourth, x cubed, x squared. Oh, I messed up. Yeah, you did, buddy. Sorry. There should be another term in here. It should be 5x to the 1 power, y to the 4th power, then a y to the 5th. My bad. So yeah, the x powers go 5, 4, 3, 2, 1, and 0. The y powers, let's do a different highlighter, go 0, 1, 2, 3, 4, 5. The last thing we have to do with all this mess right here is a lot of students will look at it and go, but wait a minute, I understand the x and the y powers, but what about those coefficients? Like, where are those coming from? Look at these coefficients. It's like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I don't like that highlighter. I'm going to have to start over. Everything is going badly today. Let's do blue. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You guys, let's just take all those coefficients and put them on their own. I guess I shouldn't have written the name of it. Way to go, Jolly. It was 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Do you guys notice any patterns here? You may have seen this before. This is called Pascal's triangle. So Pascal's triangle always starts with a little pyramid of ones, and then to be able to find the next row, you always add together the two terms that are like directly to the upper left and upper right. So it's like this 1 and 1 make 2, and then you always put fresh ones on the outsides. Then 1 plus 2 is 3, 2 plus 1 is 3, and then of course fresh ones. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and then fresh ones on the outside. So we could continue this. We could find the next row. This would be 1, 5, 10, 10, 5, 1. Wait a minute, 1, 5, 10, 10, 5, 1. You guys, these right here, aren't those the same as these? 1, 5, 10, 10, 5, 1. Those are the coefficients from the expansions. So if I was to drop down to the next row in Pascal's, this would be 1, 6, 15, 20, 15, 6, and 1. You're looking at the coefficients for x plus y to the 6th. Like if I was to do x plus y to the 6th, it would start with x to the 6th. Then the next term would be like the x power dropped down by 1, but the coefficient would be 6. So it's like 6x to the 5th y, and then the next coefficient is 15. So like plus 15 x to the 4th y squared. So notice I'm dropping my x powers by 1, upping my y powers by 1, and I'm snagging my coefficients from Pascal's triangle. The next one would be 20x cubed y cubed, then 15 x squared y to the 4th, then plus 6x y to the 5th, and then plus, that's a 5. And then y to the 6th would be at the end. Nice. So this whole method really saves us a ton of algebra, because like if I last year had asked you guys to do this by hand, oh my gosh, it would take like, 20 minutes to add all those things together and multiply everything, and you're probably going to make a mistake. The binomial theorem is all about being able to take these expansions and jump straight to this, just by recognizing the pattern of the x's always descend, the y's always ascend, and the coefficients come from Pascal's triangle. So this top row is like x plus y to the 0. This is like x plus y to the 1. This is like x plus y squared. This is x plus y cubed. X plus y to the 4th, 5th, 6th. Please notice that it's like every row is always behind one. Like the first row is not x plus y to the 1st, it's x plus y to the 0. And then the second row is x plus y to the 1st, and then the third row is x plus y squared. So it's always behind one. Also, in here, this is the first term, and this is the second term, third. So it's like, well, that's going to come into play soon. The thing that's annoying, but it's awesome that Pascal's triangle is this shortcut to get to the, to the coefficients. But if I ask you a question about, like, let's say on a test, I ask you something about, x minus 3y to the 20th, and ask you, like, what's the fourth term in x minus 3y to the 20th, which is a possible test question. That's where we're headed. You would have to build Pascal's triangle to the 21st row to find the terms, the coefficients of to the 20th. That's annoying. You don't have to build Pascal's triangle every single time. Like, sometimes I'll do it if it's like within 5 or 6 or something like that. It's just nice and easy. But anything past that, it's so annoying. So we'll get to the point where we can do something like this, and that's using this equation right here. This is called n choose r. NCR, n choose r. You can do it with this formula, n factorial over r factorial times n minus r factorial. Factorial, just a quick example. If you haven't seen factorial before, 5 factorial is 5 multiplied with every positive whole integer up to and including 5. So this would be 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. You can actually compute this if you want, but I don't want to. Yeah, it's a number in your calculator. So, quick example, I'm going to do 7 choose 3. 7 choose 3, according to our formula, says I put the 7 factorial up top, 3 factorial on the bottom, and then 7 minus 3 factorial also on the bottom. So this is 7 factorial over 3 factorial times 4 factorial. Now, if you want to go the longer, hard way, you could actually multiply this out and multiply that out and multiply them all together. But there's actually some shortcuts you can take to save yourself some algebra. Because 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. And then 4 factorial is 4 times 3 times 2 times 1. So, some things I notice here. 4, 3, 2, 1 is the same on the top and the bottom. So, you know what? We can actually cancel those out. Those are gone. Another thing I notice, 3 times 2 is the same thing as a 6. So, those are gone as well. And then, you know what? We're left with nothing in the bottom. And what are we left with in the top? A 7 and a 5? So this is 35. Look, didn't even have to touch a calculator. Although there is a way to do NCR in your calculator. We'll get to it probably next class. Okay, all of that to be able to do this problem. Expand this using the binomial theorem. Well, in this case, it's like this whole thing is going to be like the first thing, the x, and this whole thing is going to be the y. So, if I start to expand this, first of all, from the Pascal's triangle, one, two, three, wait, 0, 1, 2, 3, 4. I know that these are the coefficients of that, and that the x power is always decreased and the y power is increased. So, here we go. It's going to be something to the 4th plus 4 something cubed times something plus 6 something squared plus 4 something to the cube plus the last thing to the 4th. Now, 2x is the first part of it. It's like the algebra chunklet that comes first. So all of those are going to go here. So I'm going to go ahead and put those in. That's 2x, 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 2x. Now, the things that go in the back are just going to be y's. So here, I'm going to replace all those with y's. Now, I just have a lot of cleanup to do. So, here, 2x to the 4th. Remember that you have to raise the 2 to the 4th and the x to the 4th. That's like the first mistake I'll see. So, 2 to the 4th is what? 16? So, this becomes 16x to the 4th. Now, here, this 3 is going to have to go to the 2 and to the x, and the 4 is just going to have to chill out in front. So, this will be like plus 4 times 8x cubed, y. So that y on the back just hangs out. Then here, the 2 squared is going to be 4. So we get plus 6 times 4x squared, y squared. Then here, the 4 and the 2 are just going to chill. It'll just be like plus 4 times 2xy cubed. And then y to the 4th is just there on the end, hanging out. Now I've only got a little bit of cleanup to do. The 16x to the 4th is the same. 4 times 8 is 32. X cubed y plus 24. X squared y squared plus 8xy cubed plus y to the 4th. And then we are done. That is x. That's this. Expanded is this. Okay, you guys, you just have 6 problems to expand tonight, and then we will get into some more like nuanced stuff next class with the binomial theorem.